Okay, so the session should be recorded now. Okay, what I was saying that what you have to do, you have to go from one side, measure the pressure at different points and try to link it with the other side. Okay, that is PB. Now we know that up to this point X, we know the height. Okay, so what would be the pressure at point X? Again, if you do not look at the rest of the figure, just forget about it. Just look at point X. It will be the height, the pressure due to the height, plus the pressure that is already at this point. Okay, so it will be PA plus the height rho GH, that is 10 centimeter, and the sum of these two pressures will be equal to the pressure at point X. Okay, and that is exactly what we have done here. The pressure at point X is the pressure at point A times rho GH, and because we know H is 10 centimeter, so I have put 10 here. It should be 0.1 centimeter, but that you can correct it obviously. And the rho is the density of water, G is gravity constant. Okay, now this is for point X. Now let's go back and look at what else we can measure. So we are given what is Y, and Y is the difference between Y and X is 3 centimeter. Okay, now that is where you have to use your knowledge of isotropy of pressure. So we know that the pressure at the top, at the surface of X, is PA plus rho GH. Okay, that is 10. And what will be the pressure on this point? That is on the same plane, connected by the same fluid. So whatever this imaginary point is, let's call it X dash. So the pressure at X dash will be exactly the same as the pressure on point X. Okay. We also know that what would be the pressure at point Y. So you again have to use the same method of calculation. So if you go back, the pressure at point Y will be Px, that is the pressure at this point. Okay. And then because you are going in the upwards direction, the pressure will become negative. Okay, when you look at down, the pressure is positive because it's because of the weight of the pressure. But if you go in the opposite direction towards the height, the pressure become negative. It means that it starts to reduce its value. Okay, so again, the pressure will be the same as rho GH, and the H we know is 3. So if you look at here, it will be minus rho GH. So 3 is from the height, that is, it should be 0.03 centimeter. Then we have rho of mercury, okay, but we do not know the rho of mercury. What we are given is actually the specific gravity of mercury. Okay, so we know that the specific gravity of mercury is 13.36 times rho W. Okay, so that is the definition of the specific gravity, or from the specific gravity, because the specific gravity of mercury will be density of mercury divided by the density of water. Okay, so if you rearrange this equation, we can write the density of mercury as 13.6, that is the specific gravity of mercury, times rho W, that is the reference fluid, times G. So this is 3 rho GH. Okay. So similarly, you keep going. Now you know pressure up to this point, and you use the same trick. You go on this side, and you know that from this point to the bottom, the height is 4 centimeter. Okay, it should be actually up to this point. Sorry, not to the bottom. Up to this point, the dash is missing. And you use the same method. You know what is the pressure at this point, and then this pressure you will add to the pressure at point Y. So the pressure at point Z will be Py, that is the pressure at this point, plus the pressure due to this small height of 4 centimeter. Okay. And if you go here, you see exactly the same Py plus 4 or you can just call it rho GH and then put the values. So H is 4 centimeter, that will be 0.04 rho of oil, because we know the specific gravity, so you can calculate it by multiplying it with water times G. Okay. So similarly, you go from Z, now you go to this point. Okay. So the pressure at this point in the last leg will be PZ, because it's in the same plane, connected by the same fluid. And then from the top, you also know that the pressure at point Z, the pressure at point U would be this pressure acting downward as a positive, and then going up, this pressure will be negative. Okay. So if you try to balance the two at point U, the pressure will be Pz minus rho GH, that is 5 centimeter times the density of oil times the gravity, and plus the pressure from this side, that will be rho GH. H is 8 centimeter, G is the water itself, and rho GH. So yeah, G as a gravity. Okay, and that is exactly what Pu is. You see, Pz minus this value. Okay, and now the pressure at point Pb. Okay, you can go from here. So that will be the pressure here, and you are taking this as a negative pressure again. Okay, so minus 8 rho Wg. So why it is minus 8? Because that is the height. But why it is negative? Because you are going upward from point U to point B. Okay. And now what you have to do is you have to simplify these equations, like as you done in small in school algebra, that you have to actually sum all these units, or you have to write all these equations in the form of PA minus PB. Okay. If you just cancel out, like for example, here you have Px, and if you minus Px, Py, it will cancel out Px. Okay. Similarly, here you have Py, and if you minus Pz, it will cancel out. So obviously the signs will change. So you solve these equations by rearranging, that you get Pa minus Pb. Okay. And whatever the value will be here, you solve it further. So because obviously here I have U centimeter, so all these values will change. And if you are using meter, that is let's say divided by a magnitude of 100, you will have around 1, I would say. Okay, and then the rest is the same. So this is the kind of questions that you have to do. At least 1 or 2 questions will be that difficult, I would say. The rest of the questions will be just a simple a few step calculation, not as complicated as this one. Before I go to the next question on the chat, is there any other questions from the class? Okay, so I'm not hearing, so I suppose I will just go and look at the chat. So the question is that if the fluid isn't connected, so 2 points on different containers, one which is a lot wider than the other, and the fluid is the same in both containers. Does Pascal rule still applies if you go down the same depth in each container when the pressure is the same? Okay, so the question is that if there are, let's say, 2 containers connected, one is much more wider compared to, okay, let me try to think. Okay. I think I'm trying to just put the question, see if I can visually explain it. So there are 2 containers. One is like that. The other one is bigger, which is a lot wider than the other, and the fluid is the same in both containers. Does the Pascal rule still apply if you go down the same depth in each container? Will the pressure? Okay, I think I got it. So let's say they are saying that there are two containers, okay, and you are even actually make it like that just to explain for your. So let's say you have this much wider and this is much thinner. Okay, so this is let's say 8 centimeter. This is also 8 centimeter. Okay, and the dia here is 1 centimeter. Here the dia is 5 centimeter. Okay, that's the dia. Now the question is that if it has the same fluid, oh, you guys can see it. Okay, yes. So if this fluid inside these tubes are the same, can I say that the pressure at this point, A and B, I don't know why it is not. Let it just refresh. Okay, so this was the question, and what they are asking that if this is the shape that there is a smaller container, here there is a big container, and they are connected by the same fluid, would the pressure at this point and pressure, okay, it came now. Pressure at point A and pressure at point B will be different? No, it will be the same. Because if you remember, I showed you with this weird shape container that it doesn't matter what is the shape of the container, because what you are measuring is the weight of the fluid, okay, above this point and this point. So by making it bigger, actually, it is not making any difference up to this point. Like think about, for example, you have sea, okay? Sea, for example, how wide sea is or oceans are. And when you want to calculate how much the pressure will change, you do not take into account the surface wideness. You just look at what is the density of water, okay? So if I calculate what is the, let's say 10 meter, okay, is the, you are going in the depth of the sea, and so how much pressure will change? Rho gh. Okay, so it will be still, you will be using rho gh, and rho will be the density of water, g will be the specific gravity, and h will be the height that you are going in the sea. Okay, 10 meter. Okay, so if you do this calculation, you will see that you will roughly 1 atmospheric pressure you go down, okay, by 10 meter. Okay, so if you go 10 meter further down, you will have 2 atmosphere, and if you keep going, let's say 5 times you went 10 meter down, you will have 5 atmospheric pressure. So it doesn't really count the surface of the sea, it just count this height. Okay, and that's the same principle that you will use in this example. So do not worry about the shape or the size of the thing, just think about the height. Okay, okay. The next question is sorry, for question 2.8, how do you know the height of the tank base is 0.5 meter? Okay, so again, that question is a little bit of trick question. And here, again, you have to look at the figure that is unfortunately not very clear. So what you have calculated in this question, I think the calculation is easy. There is a trick to this question, and that's where actually the trick was put on purpose so that you understand what is happening. And as I said, that in the online test, you will not have these kind of tricky questions. Okay, this is more like to give you a chance to think about how things work. So in this question, you are to calculate what is the pressure at the center of this valve. Okay, and you use rho gh simple equation, and you calculated what is the pressure here. So on the center of this valve, the pressure was rho gh plus the weight of this, the pressure due to the weight of this lid. Okay, and but that pressure was at the center of the valve, okay, because that's where the gauge is going to be. But in the question, what you are asked is to provide you what is the total height of this container from top to the base, okay? And this pressure was not to the base, it was at the center of the valve. Now, why we are adding 1 meter and then 0.5 meters, so 1.5 meter, why we are adding it? Because this, as I said, the pressure was at the center, and it means that when you calculated H based on this pressure equation, you got the height up to the center of the valve. And then if you go lower, so the diameter of the valve is 1 meter. It means that half of the diameter of the valve is 0.5. So you have to add from center of the valve to the bottom of the valve, okay? And then you have another meter at the bottom under the valve. So that's why once you calculate this height of 1 point something, I forgot. Yeah. So once you calculate this height from the pressure equation, that is 10.87, this height is up to the center of the valve. And then you add 0.5, that is the diameter of the valve. So it means that you go from its center to the bottom, okay? And then from the bottom of the valve, you still have 1 meter, okay? And then you add this 1 meter to get 12.37 meter, okay? So now this is the height from top here to the very bottom, okay? And again, these kind of questions, the reason for that, because if you do not these tricks, you will never understand that how to get from the top to bottom. So that's why, again, we give you as a problem set so that you explore these concepts. And if you do not understand, then we are here to help you. Again, as I said, that in the e-test, we do understand that you will be on your own and you will not have time. There will be some small tricks, but not as complicated, okay? Because this goes beyond the trick, because it goes beyond understanding that you calculate the pressure at the center and then you have to go below the center. So yeah, don't worry about these tricky questions. Okay, so in exam we are expected to know the specific gravity of mercury. No, all the data will be provided to you. Again, in the problem sets or in the tutorial, some data is missing. That is missing also again with a purpose, because if it is missing, then you have to look for it. And once you look for it, it kind of sits in your mind. So for example, density of water is, if you do not know, or if it is not given in exam, even in the future, assume it as 1000. But for online test and for our exam that will be later in January, you will be given the data, okay? You will be also told what units to provide the answer in, and I would say really pay attention to that. For example, we say in this question, I will ask you, and instead of saying that give me the values in meter, I can ask you what would be the height from the lid to the base of the tank in centimeters. So if you submit the value 12.37 meter, obviously it is going to be counted as wrong, okay? So please do pay attention what the units are and provide the units, answer in units. You do not need to provide the unit itself, as if you have done the practice test, it's clearly mentioned there as well. Also, before you start your online test, there is instructions. You will have the time to read them, because the time starts when you, the 60 minutes starts when you click start. So you can read the instructions before you click start, okay? Do not put any units in the answer. You just have to put the numerical value in the units you are asked to put, okay? I hope that is clear. Last year, there were a number of kind of issues where people actually put wrong answer because they were thinking different units. Okay, there is again a question about seat code. So again, as I said, for this lecture, do not worry about the seat code. It is optional lecture. Will there be question on the buoyancy in the test? Yes, it can be, just like you guys have done one of the, for example, question in the problem set as well. Is there equation sheet for formula booklet? So because it's an online test, so everything is available to you. Okay. But as I said, please do not waste your time in kind of trying to find the values. All the values will be given. Formulas, you will have your lecture notes. And if you're asking for the exam, yes, you will be given formula sheet. You can already look in exam revision folder what kind of formula sheet is. But in that formula sheet, you will not have equations for first two lectures. The reason being because it's mostly definitions. And actually, we want you to memorize these equations, like what is density, it's mass per unit volume. So these kind of equations will not be given, but these equations we want you to memorize, okay? How many significant figures of decimal places must be right in the final answer? So normally, if it is not stated in the question how many significant figures you need to provide, you can provide two significant figures after decimal. Okay, so for example, 2.50, okay, or 2.10. It will not make a very significant difference. And just in case, if you put, let's say, too many significant figures and the Canvas auto marker, auto grader got it wrong, you can always write to me to say, okay, my answer was correct. It was just like too less or too many significant figures, and I can go and check it and I can give you the marks, okay? But as a standard rule for engineers, two significant figures after the decimal point are a standard, okay? So that is easy. If you have a complete integer, for example, 180, you do not need to write 180.00. This is only for the numbers that has a decimal point, okay, like 2.50. Instead of saying 2.5, you can write 2.50. It will not make any difference for the answer. Where can we find recording for this session? So the recording for this session, what I will do, I will upload in the lecture 2 live session, because there isn't lecture 3 because we were not supposed to run it. So I will just upload it in lecture 2 and send you guys an email about that. Are we supposed to memorize conversion of units? Unfortunately, yes. Some basic unit conversions you need to memorize anyway, if you want to be a chemical engineer, to be really honest. So you need to know the conversion between meter and centimeter. Okay, no, you don't need to know all the conversions, but some basic conversion units you should know. Meter from centimeter, similarly kilogram and pound, grams, meter cube to meter, or ml, centimeter cube, decimeter cube. So these are the basic units. But at the same time, again, this is an online test. So, I mean, if you are struggling with something, you can literally just put it online and say, what is the unit of from meter to centimeter, okay? You can do that in the online test, but obviously you cannot do that in the main exam. So please, I would say to try to memorize these units, simple units, like, as I said, meter, kilometer, centimeter, decimeter. So these are the couple of units that you should use. And from the questions that you have done, we have already exercised those units. Okay, so try to just pay attention to the problem sheet where we have converted different units going from kilogram, meter, per second square to Newton, for example. So these kind of units might be asked to you guys. Bar to milligram. Okay, that's a good question. So these, I would say, these kind of units go a little bit, they become more advanced. So what will be given to you, for example, in a question. So let's say you have to convert 30 bar into millimeter of mercury. Okay. So what I can give you in the question is that 1 bar is equal to how many millimeter of mercury? So around 760 something. So I will not give you 35 bar into millimeter of mercury. I will give you 1-to-1 relation. And then you can use that 1-to-1 relation to convert it yourself. Okay. I suppose that's the fair in the sense that you don't need to memorize more complicated units, but you just need to be able to practice them. That's the whole idea of the like this unit and also the online test. Okay. So I'm almost done with all my chat questions. So again, I open the question session. If you want to ask any question on a specific question or specific concept. Anything that is not clear to you? So no questions? Okay, still not understanding 2.6. No worries, we can go on 2.6. Okay, yes, this question is a little bit difficult to understand, but again, it follows more or less the same method that you use in 2.4 and 2.5. And what you have to do is that in this question you have to find, okay, before we go into finding, you have this system, this kind of container, and then you have two piezometers. And piezometers, what they do is that they measure what is the pressure of that fluid inside this container. Okay. And point B, or B leg of piezometer, is measuring gasoline, because only gasoline can enter. Because of the density difference, only gasoline is allowed to enter. The air cannot escape because it is a liquid seal. Okay. But at the bottom, you have a third high density fluid. So that is glycerin, and in C, it only glycerin that is measuring the value. Okay. So what these, in reality, what these tubes will give you the height, and from the height, you kind of calibrate the height with pressure. Okay. So it means that when the height of this fluid will go higher, the height inside the tube also increases, so you know how much pressure you are exerting. Now, in this question, you are given the air is 2 meter. Okay, it means the height of the air section is 2 meter, the height of the gasoline is 1.5 meter, and the height of glycerin is 1 meter. Okay, and you are asked to calculate what is the height of the fluid. Unfortunately, the color is not very dark, but if you see here, if you make a line, there is a small height here. So you need to know what is the height inside this piezometer. Okay, similarly for like B as well. So how you can start this question? So you have to again use the same analogy that I told you for manometers. Okay, and you know what is the height of this glycerin. So you go from this side, draw a parallel line on one plane, and you know that the height here is, or sorry, the pressure here would be the pressure at
Doctor,
this
did
point.
you mean to be sharing your
Oh,
screen?
I'm sorry, I didn't share. Sorry, thank you for mentioning, because sometimes, yeah. Okay, I'm sorry, I have to start again. So please, next time, if I do that, just tell me. So what I was saying, that it was this question, and in this question, you have 3 fluids, and you are given their individual heights, okay? And what the question is that what is the height in leg B of gasoline and what is the height of glycerine in this leg C, okay? And these, as I said, these heights actually are calibrated with pressure. So when the height is increased, let's say you put more air, so that more air will press them down and then the height will change. So you can actually, by calibration, know what is the pressure inside the system. Okay, so to solve this question, what you need to do is, again, you have to create points where you can compare pressure, just like we did for manometers, okay? So we know from the data that is given that this pressure of air is 1.5 kilopascal, and it is a gauge pressure. So that's, please remember that the difference between gauge and absolute. Gauge means that you are not taking into account atmospheric pressure. Okay, you are considering atmospheric pressure to be 0. And so for the air, because air maintains same pressure in all directions, so the pressure on the wall, if you put a gauge here, it will be same 1.5. And if you put at the bottom here, it will be still 1.5. Okay, so for air, please do not take rho GH thing. It is only for liquids whose density does not change. For air or for gases, the pressure in all directions are the same. Okay, and so it means that the pressure at the gasoline surface here would be 1.5 kilopascal. And similarly, based on the same logic of rho GH, we can calculate what is the pressure at this point, that is the surface of glycerin. So it will be the pressure due to the air. We know it's 1.5. And then the second thing we know that it will be the pressure due to gasoline, or this height, or the weight of this height of gasoline. So that will be rho of gasoline times G times H, and that is 1.5 meter. So it means that before I start solving this question, I know a couple of things. I know the pressure in this whole chamber of air. I know what is the pressure at this point, that is the surface of gasoline, and I know what is the pressure at the surface of glycerine. Okay. Now I can use the isotropy of pressure, and I know that if I go from surface, if I go at the same plane and reach here, that is the height here, let's call it 0.1, and let's call the small leg in tube B as 0.2. So the pressure here should be equal to the pressure here. Yes, does it make sense to you all? Okay, if it doesn't, think about the isotropy of pressure, that this point and this point, they are connected from the same liquid. Okay, similarly, you can do the same exact analogy here. The pressure at this point at the surface of glycerine that we calculated already, if you go again just in the same plane at this height, whatever this height is, we do not know this height at the moment. Okay, this height, we know the pressure will be equal. Okay, so this is the trick to the question. Once you do that, you have solved the question. So now to solve the question, we just go a little bit more. So we call this height that is, so this was 0.1, this is 0.2, but the height of the liquid in the leg B is slightly higher than 0.1 and 0.2, and we are calling it H1. You can call it HB, HC, whatever you want to call it. Similarly, 0.3 and 0.4 are the same elevation, but there is some fluid on top of this 0.4, and that's what we are calling H2. Okay. Now let's look at elevation 1. And we said that the pressure here is equal to the pressure here. And again, as I said, we can do that because it is connected by the same fluid, that is gasoline. We know the pressure at 0.1 is 1.5 because only air is acting it. Now forget about this section. Just look at this point, 0.2. Think from coming from this side only. So what is the pressure at point 2? There is atmospheric pressure because this tube is open. Okay, if this tube is closed, you don't even have to worry about that. But there is atmospheric pressure, okay, for now. And the pressure due to this very small height, H1. Okay, so what would be the pressure due to this very small height of the liquid? It would be the density of this liquid, that is density of gasoline, times g, that is the gravity, and whatever this height is, h1, we do not know the value yet. Okay, and similarly now, okay, before we go there, we can write it as p1 and p2 because we know they are equal, and you just have to solve h1, that is 0.23. Okay, so that is the height of the liquid inside this tube. And for point tube C, you use the same exact procedure. You compare point 3 and point 4 because we know at point 3 and point 4 the values are exactly the same. Subtract. Okay, there is one question, but it's gauge, so you can subtract 1 atm. Okay, so here they are asking that I suppose here we are not subtracting -1 atm because we have made this whole equation. Do you get convert 1 to Pascal to Pascal? Okay, so again, I will answer. So here the atmospheric pressure is 0 because this side of the equation we are still keeping it in gauge pressure. So we know it's 1.5 is the value of gauge pressure. Okay, and so that's why we are using this side as also whole equation as gauge pressure, because you can only compare pressure on both sides. Okay, it means that the units of both these equations or both sides of this equation should be pressure. Okay. No atmospheric pressure is what I meant. Okay, I'm coming back to the chat. Let me just explain. So 0 is because we are considering that atmospheric pressure is there, but we are ignoring to include it because we are using the whole equation in gauge. It means that we are taking the whole equation without atmospheric pressure, because if I want to use absolute pressure, then I have to add 1.5 plus 100 kilopascal or 101 kilopascal, that is equal to 1 atmosphere. Okay, then I have to change this equation from gauge value into absolute value. So I have to add equivalent of 1 atmosphere. I cannot add 1 because 1 is not the unit here. It's kilopascal. So I have to look at how many kilopascal 1 atmosphere is, and that is 101,325. Okay, that's again I know from memory, but it's like 100 kilopascal or 101 kilopascal. So you have to add it, and then on this side you also have to add the atmospheric pressure. Okay, that will be again whatever the units you are using. I think it's kilo Newton per meter square. So that is again it will be 101. So kind of cancel out anyway. Okay. And now the next question was that why I'm using 1.5 and not 1.5 kilopascal. That is also clear from the units. If you look at the units are 6.67 kilonewton per meter cube. This is okay. I have to correct. This is a mistake. It should be meter cube, but this is kilonewton as well. So kilonewton per meter cube. If you now write in this equation, so kilonewton per meter cube times meter. So meter will cancel out with one of the meter cubes. So it will become kilonewton per meter square. So Newton per meter square is kilopascal. Okay, so that's why I do not need to worry about writing kilo on both sides. I know it will cancel out. Okay, so this is how we calculate H1, and again using the same ideology of equating pressure at elevation 2. So at point 3, as I said, it's the pressure due to air plus gasoline, and that is one side. So that will be 1.5, that is the 1.5 kilopascal. I would advise you, when you solve these questions, please put the units so that you do not make mistakes. So 1.5 kilopascal plus the pressure due to gasoline, that will be rho gh. So rho g will become specific weight, and we know the specific weight is given, like here I solve it. So it's 6.67 kilonewton per meter cube times h, and h of this gasoline is 1.5 meter. So that is the one side. Now for the other side, that is the tube C. So again, the pressure at point 4, due to the small height of the fluid, it will be rho GH2. H2 we do not know, but we know rho G of glycerin is 12.36 plus 0. Why again 0? Same reason, that we are solving this whole equation into gauge pressure. And you can calculate H2. Try to solve this whole equation in absolute pressure. See if it makes any difference. Okay? And again, because you will add 101 here and then 101 on this side, that is, instead of 0, it will be 101. So you can imagine that it will just kind of cancel out. Okay? No atmospheric pressure is what I meant. Okay. I think I explained this question about no atmospheric pressure. It is not that there is no atmospheric pressure. It is more that we are taking it as 0. Okay. And please remember, okay, in the exam, what I can do. Okay. So in the online test, just to confuse you or give you a different situation, I can close this tube from the top. Okay. So think about, would it make any difference? Okay. So think about that. If I close these tubes at the top, would it make any difference to the pressure or not? Okay. And would it change the solution? It's not being considered, yes. Okay. Any other questions? Anything from the practice test that you guys didn't understand the questions? If it is closed, would it still be the same? Yes. Okay. If it is closed, it will be the same because you are measuring everything in gauge pressure anyway. Yes. So then the gauge pressure become even more important, and then you cannot solve in absolute pressure because you might end up creating more error. Okay. The simple tip that I would give you, that if, like in this equation, for example, if you have one side in gauge pressure, please make sure that the other side is also in gauge pressure. Because again, you have both equations, sorry, both sides of the equation needs to have same units. And that's why if this is in gauge pressure, this should be in gauge pressure. Last year, a number of students, they actually put this as gauge, while they forgot about that the equation has to balance, because they just thought in terms of the units. So units will be the same because the absolute pressure and gauge pressure have same units. So they satisfy the equation in terms of units, but they totally forgot about the concept of absolute and gauge pressure. Okay, so just make sure that you are solving both sides in equivalent concepts and equivalent units, gauge pressure, and also you are taking the units into account. Okay. Can you please go over the oil and water question on the practice e-test? Would it be possible to know the number? Was it, sorry. Okay, I think I should have it somewhere. just if you give me a minute, I will. Okay. Sorry. Yeah. So the questions. Let me just go to the question. Okay, I suppose it's this one. Okay, yes. So this is again a very similar question. Okay, you are given a container with different sections filled with different fluids. So you have in this section you have oil, in this section you have water, and again you are given different dimensions. So here up to this point you have H, then the whole oil from this height to this height it's 12 centimeter, and then the rest of the fluid is water and it's 8 centimeter. And then you are also given the level of the water from this point, it's 6 centimeter. Okay, so again you can see that a lot of dimensions, different fluids. So first of all, what you need to solve this question, as you guys know, this is hydrostatic pressure question, or the most of the questions are hydrostatic pressure related. So you need to know their density, the density of oil. Okay, I'm not sure if it is given. Sorry. Yeah. So the density of oil is given. So that's one thing. The density of water is given as well, 998. If it is not given, that will not be the case for online test. You can always assume it as 1000, for example, just for the sake of calculation. It's very easy. The density of water doesn't change that much with temperature and pressure. But here you are given, so you have to use this value. Please pay attention that if the data is not given, you can assume it. But if the data is given, please do not use your assumed values. Okay, do not say that, no, it's 1000. The density of water or any fluid changes with temperature and pressure. So please remember that. So it means that we can give you different values of densities. So in this case, it's 998, that is almost 1000. The next thing that is given to you are the heights, and that's the only thing that you need, because rho GH, rho is constant, more or less, or given to you. G is constant, given, I mean, it should be given, or in this question, it's not given, but it should have been given. But in the online test, if some data is not given and you needed to solve it, the whole class will get the full mark. Okay, that's the best mistake for you guys. Yeah, and H is given. Okay, so what you have to do, you have to now create points where you can solve this question. Okay, and how you can do that? So you know that the pressure at this point, that is, let me see, sorry. Just a minute, let me just try to go to the different okay. It is okay. Yeah, so let me just solve this question. Okay, so this is here is the same system. Okay, and if you now try to create the point where you can actually compare the data, so you can see that this is the point where you, like, oil and water are getting in contact, okay? And so you can create this as elevation 1. Why? Because we know what is this height from here to here. And if you, I know that we do not know yet the value of h, but we know that it's h, okay? So we can write the height of oil is what? 12 centimeters. So if you convert it into meter, it would be 0.12 plus, 0.12 plus h. So this height from this point to this point is 12, it will be 0.12 plus h. Okay, I'm not sure if it is coming on the screen. Okay, it's not coming, unfortunately. So we know this height, so that is rho of oil that we know, the G that is 9.8, and then the height that is h plus 0.12. Okay, it came, sorry. So rho of oil and G. Okay, now if you go on the same elevation, you know that this point, whatever the pressure is here, should be the same pressure at this point. Yes. So what will be the other side? We will have the pressure due to height of the fluid, that is from this point to this point. Okay. Maybe going back it is better. So look, this was our elevation point, that is this line, imaginary line here. So we know that this height is 6, and we know from this to this, based on this side, we know that this height is 12. Okay. So from this point, if you consider this point, the pressure will be rho of oil G times H plus 0.12. But from this side, if you forget about this oil part now, just look at this area here. So at this point, that is in the same plane, the pressure will be rho of water, G, that is gravity, times 6 plus 12, so it will be 0.18 meter. Okay, and because it's isotropy of pressure, these two sides should be equal, and then you have one unknown in that equation, so you can easily calculate what the h is, and h is 8 centimeter. Okay, so it means that the value might be 0.08, and then you have to convert it into centimeter, because look, what is the height in centimeter? Okay, so you cannot just give me the answer based on what you got. You have to think about what units I'm asking you, and then try your best. Obviously, yes, there can be mistakes, but try your best to be as vigilant as you can be to provide the answer in the units you are asked. Okay, I hope it is clear. Any other questions? Anything else? Okay, torque problem. Torque problem, yes. I think it's this one. Okay, just to say, torque problem is not going to be an online test. You can have the Pascal law problem, but I will not give you torque problem. Okay. Don't need to know the density of air. Okay. Before I go into torque problem, I will just answer this question. Do we also need to know the density of air? Not really. Mostly we use water. The density of air is actually not very helpful. The reason being that, if you remember, we talked in lecture 1 that the gas is compressible. Okay, So the density of air change a lot with pressure and temperature. So that's why we do not try to remember those, because we need to know temperature and pressure with density. The density of fluid also change, density of water also change with pressure and temperature, but on a very large range of temperature and pressure, they more or less stay constant. Okay, so that's why we say, okay, density of water is 1000. Yes, it might not be 1000, it might be 990, it might be 980. Would it make a very huge error in the answer? No. For a rough calculation, no. But the density of air, I think it's 1.2 something. So if you want to remember, that would really help if you want to do some quick calculation. But as such, not so much. So for online tests, I don't think so. You really need to remember. You will be given this data, okay? Uh, okay. Because I used the density of air in question 1 of the e-test, maybe I did it with a different method. Okay, I will get to question 2.7 just in a minute. I just want to check what question of density of air. So here you can actually, so there is a question on the chat that for question 11, for example, they have used the density of air to calculate the pressure, I assume. Just be careful, please, that remember that when I went in the lecture and I explained that rho gh is only for liquids, okay? And if you go back to the slides and look at the calculation, we assume that the density of water was constant. Okay, that's the only reason you could derivate that equation. In lecture 2, in-person lecture in lecture 2, I went through this very small calculation that I didn't go into detail, but I showed you that what would be the case for air, okay? And if you remember, we started with the same equation, but then I didn't take rho as constant. And I said that you have to use the ideal gas law, PV is equal to nRT, to calculate the density, because as again, the same reason, density of air or any gas changes a lot with pressure, so you cannot assume constant. So please do not use rho gh for gases. Okay, if that's what you have done and you got the answer correct, that's okay, that's a coincidence, but please do not use it can be it can lead to your wrong answer. So please do not use rho gh for air or gases, only for liquids. And again, another question about seat code. So don't worry about seat code. This session is optional. You don't have to scan it. Now going back to question 2.7. So the only thing that I think people are having problem is the torque and the moment calculation. And I think unfortunately in the schools, maybe we go through this in a very simple equations, and sometimes we miss the exact concept of this moment. So what we have to do to solve this question is use the Pascal law to calculate what is the force at point B, okay? And so to solve the pressure at point B, we need to calculate how much this lever is creating force or is creating movement, okay? So to use the moment, we know that moment is force time distance to the pivot point, okay? And that's where students get confused. They always forget that the distance is from the point of action of the force to the pivot point, and that's very important. You have to consider the pivot point. So now if you look at the force balance here, so if all the moment on this system is 0, it means that the system is in moment equilibrium. It means that the force that is acting down is equal to the force acting up, okay? Or the moment acting down and the moment acting up. So what is the moment of force acting down? It will be the force at this point times the distance from the action of the force to the pivot point, that is point C, not point B. Point B is not the pivot point, point C is the pivot point. So that will be the distance, that is 0.03 in meters plus 0.003, or let's make it simple in centimeters, it will be 33 centimeters. Okay, going from here to point C. So this is the force that is moving downwards. Now, because point C is pivoted, it means that this length of the bar will be acting in the opposite direction to this F. Okay, and that has to be equal to this force for the equilibrium to reach. It means that the force at point C that we do not know, force at point B that we do not know yet, let's call it force F1 times this distance. Okay, so that is the point where the force is acting times this distance, that is 0.03. Okay, so this is the force that is kind of, uh, because of point C being pivoted, is acting on point B. Okay, and to calculate that, we have to take into this length, that is 0.03. Now if you look at the solution, that's maybe more clear now to you guys. It's 2.7. Yeah, so this is the moment that is you are acting at point F, that was point here, that is 100 Newton. And this is the force that is negative to it because of point C being pivoted. It means that this part of the force, this bar, the force that is acting on this bar is actually upward, not downward. Why? Because C is being pivoted. So when you are applying here, this C point is moving in the opposite direction to balance the force. Okay, so what is acting on F on B is the net force. Okay, so again, if you look at it now, it's maybe hopefully more clear. So this is the force that you are acting down. This is the force that is acting up because point C is pivoted. Okay, try to think about that and you will definitely able to figure it out, that why this is upward. And that the difference gives you F1 because, again, if you are in equilibrium, it means nothing is changing. Before this cylinder starts moving, you are at a point where the cylinder is not moving. Okay, that's why it's equilibrium. It means the net is 0. You get F1. Okay, once you get F1, the rest is very simple. It's just the Pascal law. Okay, and the Pascal law say whatever force you are applying here with the whatever pressure you apply here will be translate transformed, sorry, or transmitted, sorry, yeah, transmitted to this point, and or this point, whatever, because this is the bar that will just move up. And why the pressure will remain the same? Again, because of isotropy of pressure, as we have discussed in many cases of manometer, that the pressure here and the pressure here will be the same because they are connected by the same fluid. So pressure remains the same. The thing that changes is the force. Okay, that's why you can apply less force in a smaller cross section and then lift heavy object by expanding the area. So you are multiplying the force by that area. Okay, but you are still getting the same pressure. Okay. Any other question? Is it clear, or do you want me to go or try to explain it in a better way? I'm not sure that the person who asked me is still there. So, okay. Any other questions? Any other questions, please feel free to talk or put it on the chat. Okay, I can't access the answers to problem sheet from week 1 and week 2 on Canvas. Okay. I mean, it should be available, but if you drop me an email, I can send you via email. I'm not sure why you can't access it. But yeah, please do send me an email. I can send you the answers. I suppose you are saying problem sheet. Let me just go and check. Yeah, so it should be okay. I'm not sure why it is not working for you, but it's working for me. So if you just drop me an email, I'm happy to send you this via email. Again, not really sure why it is not working. Maybe you can put a ticket to IT if that is not the problem. The answer to the lecture workshop. Okay. I suppose you mean. I think you are mentioning these ones. Again, they are working for me, and as I'm saying, I can check the settings after this session. If I can change the settings, if you still can't get it by, let's say, tonight, just drop me an email. I'm happy to send you online. Okay, in the email. It's just the new platform. I think it's still causing some problem. Could you please do question 11 because I use the density of air method. Okay, so sorry. Yeah, so the next question is that how we solve this question. And this is again, it's very similar to what we have done, question 12 and the manometer questions that you have in your problem set. So do expect that for sure you will have 3 to 4 questions like that in your e-test. Okay, so this is literally, I'm telling you. So what you have here, you have again a container with 3 different fluids. So you have air on the top, and then you have water. Okay, and then you are also given 3 different points: A, that is at the very top point; B, that is at the top of air in the second part; and C, that is at the surface of the liquid. Okay, and again, just like other questions, you are given the dimensions of, or the heights of these fluids. So air at point A is 5 meter, and the water is 3 meter here, while on the other side, water is 5 meter, has a surface at 5 meter, and then 3 meter on this side. Okay, so one thing that you need to, before you even solve question, you can tell, first of all, you know that liquids maintain surface. Okay, so the only way water is maintaining this shape is because the pressure of this air is higher than the pressure of this air. Okay, so I'm obviously I'm not going to ask you these kind of questions, but this is how you can visualize the questions. So you can see that the reason water is down here because the pressure is higher, and that's why water cannot go against it, because water wants to go against it to maintain its surface. So that's just an idea, and this kind of ideas do help you in question solving. So what you need to solve this question, you again find a point where you can equate pressures, and most of the time these points are where the two fluids meet. Okay, so that is again another hint that you can use when you are trying to find these points where you can equate, is where the two fluids meet. So that is, let's say, this point. So let's call this point as elevation 1. Okay, so what would be the pressure at what is the question? Sorry. Okay, yes. So we know what is the pressure at this point because it's given to us, that is 98 kilopascal. Okay, so we know how much pressure is here, and we are to calculate point B, that is the pressure at here. And obviously the answer you can see on the screen, but as I was explaining that without even knowing the value of the pressures, I was just telling you that this pressure is higher than this pressure, so that can help you find a good answer as well. Let's say if your answer is coming to be greater than 98, you should be saying that no, this is no way it is correct because the pressure has to be higher here. Okay, so these, as I'm saying, these kind of um, these kind of concepts, they help you understand if the answer is right or wrong. So we know the pressure at point C because the air maintains pressure equally in every direction. So the pressure at point C is 98 kilopascal. Okay, that's one thing that we know. Now, if you draw this, I think I have this question solved somewhere. Yeah. Sorry. So again, you mark this. Can you guys see my screen? I am sharing. Yes. Okay. So point 1 and point 2, that is again an imaginary point on the same elevation. And we already know that the pressure at point 1 is 98 kilopascal, absolute. Okay. Please do pay attention that this is absolute pressure now. And on this side, if you try to write the pressure, so it will be pressure due to point B, okay, the pressure because of this air, plus the pressure due to this height of the liquid, okay. And what is this height? So we know, sorry, I will go back to the here. So we know that from this point to this point, the height is 5, and this height is 3 meters. Okay, so we know this side. But from this side, we know that this elevation, and if you go in the same plane, so this point is 3 meters from the bottom because we know from this side. Yes? So what is the height from this point to this point? It is 5 minus 3 here. Okay? Is it clear for everyone? That we are not using this 3, but actually this 3, because we know that this point is at height of 3. And if we go in the same plane, it will be 3 at this point. So the remaining height of the water will be 5 minus 3, so 2 meters. Okay. Now, sorry. So we know that P1 is equal to P2 because of isotropy of pressure, and it is connected by the water on both sides. So we write on one side 98 kilopascal. On this side, we have PB plus 5 minus 3 and gamma W. Okay, so gamma W is what, if you again remember from the lecture and the problems, instead of writing rho G, we can write gamma H. Okay, gamma is just rho G from the definition. So we can write gamma W because I think data is given to us in. Okay, so in this question, we are given the the gravity, the acceleration due to gravity, but we are not given the density. It should be given in the main online test. You should have the density given as well. But for this sake of just this question to solve it, we can say that the density is 1000. Okay, so we have 2, that is the height, times 1000, that is the density of water, times 9.81 meter per second square, that is the value of G. Okay, and if you write 98 kilopascal, you will have 98,000 Newton per meter square. Okay, minus, if you solve this equation, it will be 19,000. So the answer will be around 78,000 Pascal, and if you write it in kilopascal, it will be 78.4 kilopascal. Okay, and that's what the answer is here, 78.4 or 78.3 kilopascal. And yes, is it clear now or not? So you don't really need the density of air to solve it. You use the same idea that we have practiced a number of times now to find the point where we can equate pressure and where we know the data. That's the most important thing. Here we know the height. Here we know the height because we have this height and this height, so we can easily know what is the height of this section. If you cannot find the height of this section, that would be a problem. Then you have to either assume it or you have to further complicate the solution. While in this case, it's very easy. Okay. So what is the pressure at point A is, so wait, so if the pressure at point A is 9 kilopascal, it would be the same at point C. 98, sorry, okay. So yes, okay. So what you are asking is that if the point pressure at point A is 98 kilopascal, why it is same here? The reason being, as I was explaining, that the air exert pressure. So in the case of air, so water exert pressure due to its weight. Okay, so it's vertically down, while gas exert pressure in all directions because of the collision. Okay, so where I can draw it here. So for example, if I go here and try to explain this. So look, so this is one container. Okay, for some reason my tablet is not really behaving as I want it to behave. Okay, yes. So let's say this is a container, okay? And in this container, you have air molecules. Okay, it's not really working. So let's just forget about it. So just think about that the molecules of air inside a container, they are hitting to the wall in every direction. They are colliding them with themselves and then move in every direction because there are millions of molecules, okay? And they are exerting same pressure. It means force per unit area in every direction. That is the case for the gas molecules because gas take, when you put a gas in a container, because the gas does not have a shape, it makes its shape the shape of the container. Okay, and that's, if you remember the first definition we said about the gas molecules. Okay, so they are colliding, and that's why the pressure here, one, two, I hope it will, in time it will show up, P4. Let's flash it. Yeah. So the pressure in each direction will be equal. While in the case of liquid, actually the pressure will be only towards the bottom because the molecules are not colliding. They are just moving in the lattice because of they are in a solid lattice. They can vibrate, but they cannot escape the lattice. It means that they are in a shape. And that's why the water is mostly putting pressure downwards, not in the side directions or upward direction. It's due to its weight only. Okay, so that's the main difference between gas and the liquid. So when you are saying that the pressure at point A and the pressure at point C are equal, that is 100% correct. And that is exactly the same thing that we have been solving previously. If you look at this question here, we did the same thing here, that although the value is given here at the very top, 1.5 kilopascal, but we said that at this point, it's also 1.5 kilopascal. So this is exactly the same concept that you are using in the practice test question, and you will be using exactly the same concepts in the online test as well. Okay. Any other questions? Any questions in general about the unit, about the online test? So I'm not getting any questions on the chat as well. If anybody wants to ask a question, please write it there or just ask me directly. So a lot of time I got this question from students that what kind of test it will be. So just to share, I think I didn't mention it before, but a number of questions in the practice test are actually from the previous year's test. For example, this question is from previous year. Similarly, this question is from previous year. So yeah, this question as well from previous year. So there will be a mix of questions like you have here. There will be maybe, I would say, a number of like multiple choice questions where you literally have to pick the option, while in others you have to fill a number either in multiple choice or there will be a fill in the blank. It means that there won't be a number. You have to just put your value. And in the other questions, it can be 4 options and then you pick the one. Okay. And yeah, so there will be definitely a couple of questions like this that are calculation based, then just picking the option. Okay. So any other questions, guys? Mm-hmm. Of this course, I do I suggest something for the upcoming. Okay. Not sure. You want to discuss? I mean, if somebody has just started their unit and they haven't kind of have viewed the previous lectures, I think it will be quite a challenge for them to do the test. So I would suggest that do your best to prepare for the test, but put a mitigating circumstances application as well, because it is not fair to mark you on the test. So I think if somebody is just starting, they again try your best to do the test and try to do the lectures. So view the lectures, try to do the problems, but because of limited time, I would say that they will not be able to prepare. So I would put a mitigating circumstances application, and what it means that you make a case that because you started late, you should be exempted from the test. Okay, so this decision is not by me. I cannot make this decision. It has to be to the mitigating circumstance panel. So they will review your case, for example, why you were late or why you started late. And if it is like kind of no fault of your own in a way, obviously, if the visa is late or the cars came late or whatever, I mean, the reason, they will look at all the evidence and then decide to either waive the e-test or make your exam 100% or some other decision, whatever the panel will decide. Okay, so please put a mitigating circumstances application. But for now, how to prepare for it? I would say the best thing for you would be to try to watch the lectures, because without watching the lectures, you don't know what the material is. And then if you have enough time, try to do problems from problem set 2. And on Thursday, again, there is another drop-in that people who have more questions, they can come and ask. So please then join that as well, okay? Sorry, my throat is like a little bit killing me right now because I got sick in some viral infection. Okay, so any other questions, anything else that you guys want me to explain or go over? Some confusion? And you guys don't have to stay for 2 hours as well, because I'm going to stay. So this is optional. If you don't have any questions, feel free to leave as well. If you want to stay to listen to other questions, you're free to do that as well. So any questions, guys? Two 2.3 again. Okay. 2.3. So. Yeah. Okay. So 2.3, I would say is kind of simple question that kind of help you prepare for the other difficult questions. That is 2.5, 2.6, 2.7. So in 2.3, what it actually does is kind of trying to tell you how to solve these questions where you do not have a lot of data. And the first trick, as I said, that you have to find a point where you can equate pressures. And most of the time, these points lie at the interface between fluids. Okay, so if you look at here, this is the interface, that is point A and A prime or AA, whatever you want to call it.
Doctor, you're not sharing the screen again.
I'm sorry.
It's okay, it's okay.
Yeah, thank you so much for... Yes, perfect. Thank you so much for reminding me. Yeah, totally. Because I just unshared it. Okay, so what I was saying, that this question kind of prepare you for the next questions, and most importantly, how you decide about these points where you can compare. And if you have been present in the whole session, you know that we solved a number of questions where we took different elevations and then try to compare. So this is a much simpler question, but this is very important to understand how to do this comparison. So now here I have selected point AA, and why I have provided you in exam, it's very unlikely you will have these points provided to you. But here you can see that there is an interface present. So that is one hint. And second thing is that this is the point where you can equate two pressures. Okay. So how you can do that, if you look at this side only, forget about this whole side, just look at this point. So if you, let's say, know the value of H, that is 5 meter, can you calculate what is the pressure at this point? Okay, so the pressure at point here would be the pressure due to the fluid, that is PB, whatever the value. Don't worry about the value right now. We are just writing the expression. The pressure at point PB plus the pressure due to this weight of the liquid. And what is this weight of the liquid is rho GH. So rho of the oil, okay, that is given to us. So it's 0.88 specific gravity. So if you have the specific gravity, you just have to multiply it with the density of water to get the density of the liquid. And G is a constant and H is 5 meter that is given to you. So you already know what is the pressure at this point. Yes. Now, in theory, we know that if the 2 points are connected by the same fluid, the pressure at point A and the pressure at point A prime, let's call it, should be equal due to isotropy of pressure. So what is the pressure at point A prime? Now forget about this rest of the manometer, just look at this side. So the pressure at A prime, or at this A, is the pressure due to water, that is PA, plus the pressure due to this point here, okay? And what is this point? So that is, this height is, if this height is h, and it will be h minus 2, yeah, because from here to here it's 2, and if the total height is h, the blue height in this section will be h minus 2. Again, this is, you can calculate this number if you know h, but forget about the numbers at the moment, just think about the expression. So that is the h given to you, that is h minus 2. But the pressure at point A prime is the pressure due to water and due to this fluid, that is mercury or whatever this fluid is. So you also have to add this liquid as well. And the weight of this liquid will be rho GH. H is 2 meter, as it is very clear. G is constant. And rho of this would be, if it is not given, obviously you have to find it. But in this question, it is given 1.25. So you know the density of this fluid as well. So now if you go back to more detailed question solution, so yeah, so on point here, the pressure is PA plus the pressure due to the water, that is H minus 2, that is the height of this thing here, times the density times G, and sorry. Yes, sorry. Okay, sorry. I missed that part. So yeah, so that will be rho G delta H. So this delta H actually is this 2 meter, and that should be equal to the point here, that is PB plus rho GH. Okay. So again, you know what this rho is. It's given 5 meter. So you literally just have to plug the values in the equation, and you will have your answer PA minus PB. Okay. So if you take this equation from this side to this side, it will be PA minus PB, or you can decide to take it PA to the other side and it will be PB minus PA. So the answer will be same, just it will be a negative depending on if you are using PA minus PB or PB minus PA, depending on which pressure is larger among the two. Okay, so this is how you can solve more complicated questions as well, by identifying the points where you can equate pressure from different sides. Okay. Next question is the atmospheric pressure always be the pressure outside the system, even if the system is closed? Yes. So think of it that you have a container, and that container is a box that is sealed, and then inside you have some pressure. Yes. But the only way you can measure the pressure inside that box is by using a gauge. Yes. And if you measure the pressure inside this chamber by using gauge, that gauge is still functioning based on the atmospheric pressure, because the gauge is outside the chamber. Okay. So you are although measuring the gauge pressure, but still it is with reference to the atmosphere. Okay. Unless you put the whole chamber and the gauge in a bigger room with complete vacuum, and then that gauge will be showing you the absolute pressure. Okay. So this is again going back to the same discussion about this balloon thing that I showed you, that you have a balloon, and if you put pressure from the outside, obviously the pressure inside the balloon goes higher. And if it is the atmospheric pressure, if you increase it, you will see a smaller value on the gauge pressure, because with the reference to that you are measuring has increased, so now you are showing less pressure. While if you release the atmospheric pressure, go into vacuum, your gauge pressure will start to show higher value, because now you have less counter effect from the atmospheric pressure. Okay, so think about this reference to and counter mean, what it means. Okay. Okay. Could you please explain 2.8 again? So 2.8. Okay. So in question 2.8, so it is actually, I would say, fairly easy question. There is only one trick that we kind of want you to know, and the trick is about the valve. Okay, the rest of the question is simple. You just need to know rho GH and a little bit of calculation, but let me just go over it quickly. So you have a tank, and in this tank you have a fluid with density of specific gravity of 0.9. Okay, and you also know that there is a lid on the tank, so it's a floating lid, and it is 5,000 kilonewton. It means that you know you know the weight of this lid. Okay, and you need to calculate what is the height of this tank from top to the bottom. Okay, and it also says what will be the oil height from the tank base if the maximum pressure at the center of the valve does not exceed 1 bar. Okay, so this statement is giving you a hint that at the center of the valve, if you kind of look from the outside, it is measuring 1 bar. So this is another way of saying that you are calculating the height of this liquid through the valve at the center point of the valve. Okay, and so if you now look at the question solution, let me just go there. Okay, so as I said, we know a number of things. We know the diameter of the tank, not the diameter. It's actually the base, D40, and we know S is 90 specific gravity. We know the weight of the cover, and we need to know what H is. So we know that the point, if you look at the figure, the pressure at this point at the center where the gauge is, the pressure will be the pressure due to the fluid up to the gauge center, plus the pressure that the lid is exerting. So there are two mechanisms of pressure. One is the weight of the fluid, and the second is the weight of the lid. And that's exactly what is written here. That the pressure is the pressure due to oil and the cover, and the rest you just have to open it. You know the density of oil is, because you know the specific gravity, so the density will be specific gravity times the density of water times G, and H we do not know. And cover, for the cover we know that the weight is 5,000 kilonewton, but 5,000 kilonewton is the force, not the pressure. Okay, so to convert force into pressure, we know that pressure is force per unit area. Yes, and we also know that the diameter of this of this tank is 40. So we can write it as pi by 4 d square, or if you are more familiar with pi r square, then you have to divide d by 2. So that will be 20. Okay, so it will be pi r square, and that will be 20 meter. Okay, so if you convert now this force into pressure, it will be 3.94 kilopascal or 4 kilopascal, let's call it. And then the total pressure would be 100 kilopascal. And if you kind of rearrange this equation, you can calculate H, that is 10.87 meter. but this H is actually at the center of the valve. Okay, so now if you look, although this figure is not the best clear, but this is the pressure at the center of the valve. So it means that to go to the base, you still need to add a bit of height. And that height is that the valve itself is 1 meter from the bottom, that is 1 meter, and the valve diameter is 1.5. So to its center, you have half a meter. Okay. So it means that from this center going down, you still have to add 1.5 meter to get to the base. Okay. And that is 1.5 meter to the base. Now, the question is that why we are adding this 1.5, because the gauge that you are measuring this pressure is actually at the center of the valve. If you decide to put a valve at the bottom, let's say instead of putting on the side, you put it at the bottom, then you do not have to worry about this height. Okay, then you just go from top to the very bottom, because the valve itself will be at the bottom. We do not put valves at the bottom in reality. Why? Because it can get hit, it can break. So that's why we give some space at the bottom to for safety reason, because first of all, this will be at the floor, or it will be on the ground, or even on a tanker, wherever. So that's why this side is more safer. And as you can see that it's almost 1 meter from the bottom as well, so that it doesn't get hit and break, because if it breaks, it means that the oil will leak as well. So that is a practical reason for putting the valve on this side. Okay. But if you have a valve here at the bottom, then you just do the calculation without adding this 1.5, and the height will automatically will adjust because of that the valve is at the bottom. Okay. Regarding the Archimedes law, what happens to submerged object if the buoyancy is equal to the weight? Okay, that's an important question. So if the buoyancy is equal to the weight, so look, it's easy to think like that. So buoyancy is the force that is pushing it out, yeah, or pushing it upwards, while the weight is that is pushing it down. Okay. So where the weight and the buoyancy become equal, it means that the object will be swimming just under the surface. It will not be at the bottom, but just under the surface of the liquid. It will be floating like that. Okay. So that's where the two forces will be equal. Yeah. Any other questions? We have 4 minutes. Okay, thank you so much. Before we close, any last questions? Okay, if there are no more questions, I just want to thank you for joining. And again, there is another drop-in on Thursday. If you still have any questions, please feel free to join, and I will be happy to answer your questions. Okay. So all the best of luck for your preparation, and I hope you have a good or great online test. Okay. Perfect. Thank you, everyone. Bye bye.
Thank you, Doctor.
Yeah. Thank you.